All right, Optima has a quilt shop where she sells many colorful quilt blocks for people who want to make their own quilts. She has a quilt design that are made up so they can be sized to fit any bed. She bases her designs on quilt squares that can vary in size, so she calls the length of the side of the basic square X. So if this is a basic square, this is size X, okay? And then the height is size X. Well, how do you find area? You should be writing this down. Area is length times width, so X times X, or X squared. So the area of the basic square is the function area given the side length X equals X squared. In this way, she can customize the designs by making squares bigger or smaller. You should have this white paper out on your paper and you're doing it with me. Okay? If Optima adds 3 inches to the side of the square, what is the area of the square? Okay, so here's the deal. Here's her basic square. And it has a length of X something, and then she adds 1 inch, 1 inch, and 1 inch on this side, and 1 inch, 1 inch, and 1 inch on this side. Okay? And remember, we talked about these diagrams several times. Is there anybody that does not have this paper? Do you have this paper? Did you get it from over there? Are there still white ones over there, Mr. Meyer? Okay. All right. So this is what it looks like. If Optima adds 3 inches to the side of the square, what is the area of the square? Well, this is the picture. Okay. How do you find area again? Length times width. So what's the length? Okay, I'm going to make you guys talk about your group then. Here's the deal. I'm going to claim that the area is either this. A of X is X plus 3 squared. Or it could also be written like this. Okay? Talk with your group. Explain why these are the areas of the square. Look at the picture. Look at the algebra. Talk with your group. Yeah, guys, look, it matches the picture. Here's your X squared. Okay? Here's your X squared. And then, how many X's do you have? It says 6 X's. Well, this comes from, this has a length of 1 and a width of X. 1 times X is X. You have 1, 2, 3, 4, 5, 6 X's. And then we have a 9. Well, 1 by 1 is a unit 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. That is how come you have X squared plus 6X plus 9. Anybody else? What else did you notice? Yeah. So it's X. She's right. It represents one side of it. X plus 3, right? And then actually it's X plus 3. So you really have X plus 3 times X plus 3. It's length times width. Guys, it's the area formula. Now, if you multiply this together, X times X, there's X squared. X times 3 is 3X. 3 times X is 3X. And 3 times 3 is 9. Also, algebraically, it turns back into the other version. How come we don't have a number for X? Does anywhere in the story problem she tells us the original amount? Guys, yes, no? She does not tell us the original amount in the beginning. She just says she has some square with a length of X and a width of X, and that she's going to add 3 inches to the edge of it. So that's why this part is X, because we don't know the original amount. Okay? All right. A customer service representative at Optima Shop customer service representatives work with customer orders and write up the orders based on the area of the fabric needed for that order. As you can see from problem number 2, there are 2 ways that customers can call in and describe the area of the quilt. One way describes the length of the sides of the blocks, right? That's what we said. One way describes the length and the width and multiplies it together. And the other way describes the areas, added up all the pieces. Okay? We're going to do some more. And instead of you having to draw it, we've drawn it for you and you have to highlight the right area. So it says, for each of the following quilt blocks, color the block area that matches the expression blue and write 2 equivalent expressions for the area of the block. So for example, isn't this x plus 3 right here? But what do we really want? So it would be x plus 1, 2, x plus 2. Instead of you guys having to draw it, we just want you to shade in what it's really supposed to be. It's really supposed to be that. Technically, I could get rid of, you don't have to. So we're just trying to make it so you don't have to draw as much. Would you guys agree that's the correct picture? Okay, so what I want you to do is to shade in number 3 and 4, and then give me the 2 versions. Give me this version, and give me this version. Work with your group. So you should have a of x equals something squared. Give me the 2 versions. Do 3, 4, and 5. All right, so the first one, if you look carefully, it has a length of x, that mystery amount, plus 1, 2. Right, that's the length, and x plus 2, that's the width. X plus 2 times x plus 2 becomes this. The other way to think about it is we have 1x squared plus 1, 2, 3, 4 x's plus 1, 2, 3, 4. There we go. Any questions on that? Okay, does somebody want to tell me what you got for this one? I'll shade it in. It's our x squared, or an x plus 1 times x plus 1. So it looks like this. The rest of it's just extra. Okay, we don't really need this. Okay, it says, what do you notice when you relate the diagrams to the 2 expressions for area? Does anybody notice anything in particular? What if I did this? What if I added the one from before? So remember that first one was x plus 3 squared and x squared plus 6x plus 9, right? That was the first one. How do these relate? How does the pink number on all of these relate to the orange number? And how does the pink number relate to the purple number? So pink is 3, orange is 6. Pink is 2, orange is 4. Pink is 1, orange is 2. How do they relate? Yeah, so the pink one, 2 times the pink one equals the orange. Did you guys figure that out? Okay, what about the pink to the purple? The pink to the purple. Connor, help her out. Times it by itself. Square it. Okay, the pink times the pink, or the pink squared, equals the purple. Optima likes to have her little dog Clementine around the shop. One day the dog got a little hungry and started to chew up orders. When Optima found the orders, one of them was so chewed up that there were only partial expressions for the area remaining. Help Optima by completing each of the following expressions for the area so that they describe a perfect square. Then write the 2 equivalent equations for the area of the square. So let's see, I'm going to start by drawing a picture. I have an x squared. And I have 4 x's, but I know that I can't put them all right here because then it's a rectangle. We want a square. So we put half of them here and half of them here. This is the part that the doggy ate. What's going to go in there? Would you guys agree that it's 4? So let's look at the length of this rectangle. It's x plus 2. Which does that gives me? That gives me an x squared. Okay, it gives me an x squared. How many x's do I have? 1, 2, 3, 4. That's what they already told me. That wasn't a surprise. I already knew that. But then how many ones? How much did I need to complete the square? 4. So you can do this using the pattern we discussed, okay? Or you can draw the pictures. In your group, please do B, C, D, and think about F as well, okay? So for time's sake, what is the relationship between B and C? Remember, we had ax squared plus bx plus c. What is the relationship between B and C? Can anybody see anything for me? Beautiful. If you take B and cut it in half, so let's see, 12 divided by 2 is 6, and then square it, 6 squared is 36. Let's try it again. So what if I had x squared minus 10x? Could you get me a number that goes right here doing that? But algebraically, guys, if we did half of b, well, that is negative 5. You guys good with that? Negative 5 squared is, 25. So does it work? Yes. Why? What makes it work? The negative times a negative makes a positive. Good job. Negative 5 times negative 5 makes a positive. All right. Last but not least, okay, what if the middle number is odd? X squared minus, now I'm going to do 5x, or plus 5x. It does work, but let's see how it works. What's half of 5? What's half of a $5 bill? $2.50, right? And 250 squared is 6.25. So it does work, but what happens if it's odd? C is a decimal or fraction. And I'm going to draw you a picture to go with that. Okay, so what we have is we have x squared, and then I've got 5, so I got to do it in half. 1, 2, and a half of 1. I'm going to make those bigger so it's easier to draw a half. 1, 2, and a half. 1, 2, and a half. Now let's draw my picture. Let's see, do I get 6 1/4? 1, 2, 3, 4, 5, 6, and 1/4. Okay, so it does work. What you needed to get out of today is that half of the middle number, half of b squared, will complete your square. Okay, half of b times itself will complete your square.